Hey everyone, on this PowerPoint we're going to be looking at climatic impacts on soil formation. I hope the video was exciting for you. I wanted to show some extreme weathers because we are going to be talking about weather as it relates to climate. So climate is defined as the average weather over a period ranging from months to thousands or millions of years. The classical period is 30 years. So while we did look at all those extreme weathers, we're going to be talking about more long-term, everyday, every year type of stuff. Though there can be areas that are more prone to things like hailstorms and wind, etc., like we saw in the video. The quantities that are most often surface variables are temperature, precipitation, and wind. I don't have a specific slide for wind, so I did want to touch upon it. Sand can be carried by wind and abrasive against rocks when it's blown into them, breaking them down and weathering them faster. And then wind can also speed water movement, etc. Climate plays a definitive role in the breakdown of rocks into soils and sediment. That's known as weathering. It is the most significant factor controlling the type and rate of soil formation, so climate is pretty important. The dominant climates are recognized as arid, humid, oceanic, Mediterranean, continental, temperate, and tropical and subtropical. We're going to go over those next. So in an arid climate, the rainfall is way less than what the soil would like to have, and they remain dry for most of the year. So if you imagine a place like Las Vegas, that would be an arid climate. An oceanic climate is more cloudy with rain, though it can have clear sunny days, and it gets a moderate amount of rainfall, and the temperatures don't seem to get too hot. A good example would be London or possibly Ireland. So a good example of a Mediterranean climate would be Santa Barbara, and I can speak from experience. I've lived here for several years now, and We get moderate precipitation in the winter, and the summers tend to be dry and hot, though I would say lately our rainfall, like the rest of California, has been pretty low, unfortunately. In a continental climate, you have warm summers and extremely cool or very cold winters. So think of someplace like Toronto, Canada. A temperate climate tends to be cold, and then humid conditions in the warm summers. And a good example is New York City, and I would agree. I went there just once, and it was very, very humid weather. In a humid climate, the rainfall is more than the water need, and that excess water actually results in leaching of salt in the soils. A good example would be Mississippi or Tennessee. Think about like when you go there, you take a shower and you get out and you're still sweating. Like it's so humid, you just can't get rid of that feeling. Tropical and subtropical climates are really warm to really hot with humid isothermal conditions. A good example would be Florida. So you've got that humidity, but then you add a lot more heat to it through most of the year. So active soil forming factors include climate, which we're talking about, and in climate you have precipitation and temperature. So climate affects the soil formation process directly by supplying water and heat to react with parent materials. So think of streams and rainfall, rivers, and the breakdown of the rocks by water, and then sun also weathering them down over time to create soil. And then the climate can affect soil formation indirectly by determining what types of plants can live in those areas. So if you think of a desert, there's obviously less flora and fauna that are going to be acting there than, say, a humid or a subtropical area. So this energy acts on the rocks and minerals when they break down in the form of acids, and then salts are released. So this indirect effect of climate on soil formation is most clearly seen in the relationship of soils to the vegetation. So looking at the more direct climate effect on soil formation, that would be precipitation and temperature. Temperature and moisture influence the speed of the chemical reactions, and that controls how fast the rocks will weather and the dead organisms will decompose. So if it's really, really hot, things break down faster. If it's really cold, they tend to keep into their current state. So soils develop faster in warm and moist climates and slower in cold and dry climates. Here's a quick video that discusses some of the topics I've already touched upon. Maybe you'll like his voice better, and it does have a few good photos in it.
Primary factors that come from the climate are how much moisture or water is available in the soil and the temperature of the soil. For example, more moisture in the soil increases plant and microbial growth, which contributes to the breakdown of soil. In addition, this increases the amount of organic matter that is found in that soil. In contrast, low moisture in soil reduces the amount of plant and microbial growth, which reduces the amount of organic matter and slows the breakdown of soil. This thereby reduces the amount of humus that can be found in that soil. In another example, low amounts of moisture in the soil coupled with high temperatures promotes evaporation. These characteristics reduce the removal of calcium carbonate from the soil, and areas that have this type of climate generally have higher pH values in their soil.
You know, and that's something I've actually seen in Santa Barbara. We have areas that are pretty dry and hot, and the soils are very thin and lack a lot of organic material, and they have a lot of calcium carbonate. So we have sections of our avocado trees that will turn yellow from iron chlorosis, and we have to, you know, do soil amendments and mulch and sometimes acids and things to help mitigate that issue. So here's a chart showing at the top from west to east and the effect of climate on soil pH and calcium carbonate in the soil and also humus accumulation. So obviously in the west you can see that there's way more calcium carbonate in the soils than in the east, and that has to do with, you know, the different temperatures and the different climates moving across from more of an arid to a more humid and subtropical climate in general. I wanted to include this chart that I also found online that shows the different climates, as you can see down here: tropics, desert, temperate regions, and then Arctic. You can see the different flora and fauna that tend to grow in those areas. Also, the rainfall is listed above in a generalized, manner. So you can kind of see the soil depth of humic material in the tropics and the temperate regions as opposed to the desert or frozen tundras. Here's a good comparison for all of you visual learners out there. The climate, the moisture and temperature affect what vegetation can grow in an area, thus affecting the soil formation process. So on the left we have sun and rain, more moisture, and it has a vegetative cover, so it's obviously not too hot there, and there's more nutrients and moisture in the soil. You can just see a lot more activity. And then on the right there's no vegetative cover, so we would think it's more of a desert-like climate, and then lack of moisture in the soil, and lack of decomposition happening, so not really an organic layer and not a lot of soil forming going on. Okay, so because you were paying such fabulous attention, I know that you are going to just ace this quick quiz. We're going to do a fun way, and we're just going to shout our answers at the computer. All right, so first question: what are the two main ways in which climate affects the soil formation? So I'll give you a few seconds to yell out at least one of them. All right, so the first one is precipitation, and the second one is temperature. Next question is: what are three types of climate? And we went over this at the beginning of the presentation. So hopefully you've shouted out at least one or two. There are a total of 7. And I'm just going to give them to you all now. So arid, oceanic, Mediterranean, continental, temperate, humid, tropical, and subtropical. Our next question is: does soil develop faster in arid or in humid climates? Give you a second. Hopefully you yelled out that soil develops faster in humid climates. So we learned quite a bit today: the 7 types of climate and plenty of examples of each, that temperature and precipitation are the main factors in climate. We learned the difference between a soil with vegetative cover versus not. We learned that soils develop faster in warm, humid climates than in cold, arid climates. Temperature and moisture influence the speed of chemical reactions, which control how fast things weather and decompose, and climate affects soil formation directly and indirectly. Thank you for your attention and your participation.